Start recording. On Monday, we started talking about disjunction and conjunction, those compound statements. A compound statement is a statement involving two or more simple statements. And we have logical connectives to connect those simple statements to make a compound statement. And so far, we have learned three logical connectives. They are negation, disjunction, and conjunction, right? So if we have a statement P and we place this negation symbol in front of the statement, we have the negation of P. So it's the negation of P. Negation is a mutual relationship. If not P, we call this as not P. This is not P. If not P is negation of P, then the other way around, P is also a negation of not P. In other words, P and not P are negation of each other. Those two statements always have different truth values. If P is true, then its negation must be false. If P is false, then its negation must be true. All right? I think it's very straightforward. For disjunction, this connective is called disjunction. If we use this connective to connect two statements, P and Q, we have a disjunction. This disjunction means P or Q. This means P or Q. And how do we understand P or Q? Or here is the inclusive or. Inclusive or. P or Q means either P or Q or both, right? And if we use this connective to combine two statements, then we have a conjunction. Conjunction means P and Q, both. The beginning of today, I want to work on the truth table for those three types of statements. The statements involves negation, disjunction, and conjunction. What is the truth table? Truth table is also called the truth value table. It's a table that we can analyze or determine the truth value for a compound statement based on the truth values of its simple statements. For example, let's start from negation. Not P. Not P. The truth value of not P depends on the truth value of P. As negation of P, not P has the opposite truth values with P. So we can make a table to demonstrate that. The first column we give P, second column is not P, not P. Since P may be true or false, right? Any statement is a sentence either true or false, but not both simultaneously. We have two options to give the truth value for P. So we have two cases, case 1 and case 2. P is either true or false. In the case P is true, its negation is false. For example, if P represents London is the capital city of England, then P is a true statement, is a fact. We know London is the capital city of England. Then its negation, which says London is not the capital city of England, would be false, right? excuse me. The second case, suppose P is false, then its negation is going to be true. For example, if P represents a false statement, let's say 1 plus 1 is not equal to 2. Let's say P is 1 plus 1 not equal to 2. Is false, obviously, right? Then its negation will be 1 plus 1 equals 2. It's going to be true. So the negation of a statement always have different truth values. This truth table, this is the truth table for negation. It is very simple. This is the simplest truth table. I believe everybody can understand the truth table very quickly. Next, we are going to talk about the truth table for a disjunction. This is the disjunction notation. It connects two statements and make a compound statement. The compound statement is a disjunction. The truth value of this disjunction depends on the truth value of the two pieces. When I say two pieces, I refer to the one piece to the left of the symbol and the other piece to the right of the symbol. So the truth value of P or Q depends on the truth value of P, also depends on the truth value of Q. For that reason, we need to make a table to demonstrate the truth value for the disjunction in different cases. The first two columns, we're going to have the truth values for PQ. Those are the two pieces in the disjunction. The last column, we're going to have P or Q. All right? Yeah, let's think about how many different combinations of truth values do we have for PQ? If we consider this task, this is P, this is Q, we want to put a truth value, pick a truth value for P, and then pick a truth value for Q. This task has two steps, right? The first step, we pick a truth value for P. P could be true or could be false. So we have two different ways to assign a truth value for P. The statement is either true or false, not both simultaneously, right? So we only have two different options to assign a truth value for P. Same thing for Q. Q is also either true or false, right? We also have two different options to assign a truth value for Q. Remember the fundamental counting principle. The famous fundamental counting principle tells us we should multiply the two numbers to get the total number of ways to assign truth values for both of the two simple statements, and that is 4. I know in this case, 2 plus 2 is also 4, but remember fundamental counting principle does not apply addition. We use multiplication when we apply fundamental counting principle. 2 times 2, 4. That tells us we're going to have 4 cases for the combination of the truth values of the two pieces in the disjunction. Case 1, case 2, case 3, case 4. What are the 4 cases? What are the 4 cases? Consider the truth values for PQ. Consider the truth values for PQ. You know, the two pieces PQ could be both true, right? That is one case. Could be both false. That is another case. It also could be one true, the other is false, right? So let's see. Let me give you the 4 cases. The first case, both are true. Second case, P is true, Q is false. Third case, P is false, Q is true. The last case, both PQ are false. There are only 4 cases when we consider the truth values for the two simple statements PQ. You will not find the fifth case. All right, only 4. And by convention, we want to always follow the same order. You're going to be very familiar with this, the first 2 columns in the table. To assign truth values for PQ, just remember the order. 4 cases. The 4 cases are TT, TF, FT, FF. Technically, if you mess up the order, it doesn't change nothing. But as I mentioned, by convention, we want to follow the same order. TT, TF, FT, FF. All right. So we have 4 different cases for the 2 pieces, for the truth values of the 2 pieces in a disjunction. Okay, now let's see, how do we determine the truth value for the disjunction in the 4 cases? Again, by the way, the 4 cases will not happen at the same time, right? It's either case 1 or case 2 or case 3 or case 4. In different situations, how do we know the truth value for the disjunction? Let's start from the first one. P is true, Q is true. Would that make P or Q, disjunction means or, a true statement? What do you think? P is true, Q is true. Would that make P or Q a true statement? I heard you type some answers. Let's see. What do you have? Yeah, of course. I agree. You know, P is true, Q is true. P or Q, of course, is true as well, right? What about the second case? In the second case, P is true, Q is false. P and Q, one is true, the other is false. Would that make the disjunction true or false? Does that make this? I'm sorry. Anybody want to say something? You know, I want to ask you a question, guys. Let me type the question in the chat. My question here is, what takes to make P or Q as true? In order for the statement, the common statement, P or Q to be true, what it takes? What it takes to make P or Q to be true? Do you kind of agree P or Q to make P or Q to be true? P or Q to be true is to make at least one of P, Q to be true. Do you agree that? To make a P or Q to be true. What it takes to make a P or Q a true statement. To make a P or Q a true statement, we want to make either P is true or Q is true or both is true, right? Does that mean at least one of them is true? Yeah. So it means the same thing. So I wrote it here. Very good. Thank you. If you missed the roll calling, please remember to message me, email me later, okay? Yeah, so P or Q is true is the same with at least one of the two simple statements is true. So now we can answer the question, what it takes for P or Q to be true. It only takes at least one of the two statements true to make a P or Q is true. Even the other is false, it doesn't matter. At least one, right? Of course, if both are true, then P or Q is very true. It's very true, still true, right? So that gives us the second case. P is true, Q is false. The disjunction is true because at least one is true. Yes, P is true. That satisfies at least one is true. Same with case 3. When P is false, Q is true, the disjunction is still true. The only case the disjunction is false is when both pieces are false. All right? In order to make the disjunction P or Q to be true, it takes at least one of them is true. But if none of them is true, then the disjunction definitely cannot be true, has to be false, right? So I want you please write down this conclusion, this sentence. I want you to memorize the sentence. Whenever you need to consider the truth value for a disjunction, I want you right away think that sentence, the sentence I'm going to write down. The only case a disjunction is false is when both pieces, ECES, are false. And here, I'm sorry, I use pieces. You don't see that in the book. It's just I think to refer to pieces is easier later when I explain questions. So any disjunction has the disjunction symbol in the middle, right? And the symbol connects two parts. One part on the left, one part on the right. And I just call those two parts as two pieces. So in order for disjunction to be false, both two pieces have to be false. And that's the only case a disjunction is false. Disjunction kind of like a low maintenance. To make a disjunction be true is pretty easy. It only takes at least one of them is true, right? So the only case a disjunction is false is when both pieces are false. So I want you can reward it to make yourself feel comfortable. I want you always remember this sentence when it comes to the truth value of a disjunction. To make a disjunction, so only case a disjunction is false is when both pieces are false. When you see both two pieces are false, okay, the disjunction is false. That means in other cases, when the two pieces are not both false, the truth value for P or Q is true, is T. Do you guys have any questions about the truth table of a disjunction, of the disjunction compound statement? Very good, perfect. And now let's look at conjunction. You're welcome. Now let's look at conjunction. Notation P and Q. This upside down V is the symbol for and, is the symbol for conjunction. Same with earlier, this connective connects two parts, right? One part is to the left, the other part is to the right, and I'm gonna continue referring them as pieces. So in a conjunction, we also have two pieces. Sometimes the pieces are simple statements. Sometimes there are more complicated compound statements. You will see what I'm talking about later. So just know that the conjunction symbol connects two parts, the purple part and the yellow part, right? I refer to them as pieces. In the conjunction, we have two pieces. Then the truth value of this conjunction obviously depends on the truth value of the two pieces, right? And okay, the two pieces in this case are just two simple statements. One piece is P, the other is Q, and the last column we have P and Q. And same with earlier, we only have 4 cases for the truth values of the two pieces PQ. The 4 cases are TT, TF, FT, FF. Please always follow the same order. Okay, TT, both true. TF, P is true, Q is F. FT, P is false, Q is true. FF, both are false. Let's see. In each case, how do we determine the truth value of P and Q? Okay, answer this question. Yeah, the conjunction again, conjunction is and. Conjunction is and. Conjunction is and. Answer this question. What it takes to make P and Q to be true? What it takes to make a P and Q to be true statement, to be a true statement? Yeah, how do we do to make a P and Q are true as true? That is for disjunction. At least one is true is for disjunction because that means or. So do you guys remember the set theory in chapter 2? When we talk about or, let's say this is P, this is Q. Or means this region. At least one, right? At least one of the regions. And this part is a P is true, Q is false. And this Q is true, P is false. And the middle is both of them are true, right? You can understand that like that. Let's give it a little bit time. This is P or Q. But P and Q, guys, P and Q is stronger. P and Q is stronger. P and Q is the common part, all right? Think about to make a P and Q to be true, what it takes. Exactly, thank you, Chloe. When they are both true. Yeah, Ashley, thank you. Yeah, so think about to make a P and Q to be true, both P and Q have to be true. Exactly, very good. And conjunction is a lot more high maintenance. It's not that easy. I think my computer is freezing. Let's give it a little bit of time. Okay, reacting now. Double check. It's recording. Okay. To make a P and a Q to be true, both of them have to be true. So here, the sentence I want you to memorize when it comes to determining the truth value for a conjunction is the only case in which a conjunction is true is when both pieces are true. It cannot like repeat itself, right? What takes to make a P and Q to be true? Both P and Q, they must be both true. Then P and Q is true, right? For example, 1 plus 1 equals 2, and 1 plus 2 equals 2. This is a common statement, is a conjunction, right? How do you make this? Is this statement true? Is this statement true? 1 plus 1 equals 2 and 1 plus 2 equals 2. They are not true, right? This common statement, the conjunction is not true because this P is rounded. 1 plus 2 is not 2, it's 3. To make a conjunction to be true, both pieces must be true, all right? Very high maintenance. So among the 4 cases, only the first case, both pieces are true. And in that case, P and Q is true. Other 3 cases, false. All right? Like a P and Q is very high maintenance. Even just a little bit false, the whole thing is not false. It is not true, right? Yeah, let me highlight this conclusion. I need you to memorize the sentence. The only case a conjunction is true is when both pieces are true. Any questions, guys? Okay, awesome. Thank you for your response. Very good. So we spent time covered 3 truth tables, right? The truth table for negation, I believe you should all know how to find the truth value for a negation based on the truth value of the original statement. And also we covered the disjunction truth table and the conjunction truth table. And next, I'm going to start the next type of, thank you, Ashley. The next type of compound statement is called a conditional. Okay, we're going to start talk about conditional. My system start become very slow. Let me see if I can close that and then start a new page. Maybe it would make it faster. Instead of continue from here, I'm going to start a new page. Maybe that page is too much stuff there. Okay, I hope this fixes the issue. Okay, next we are going to talk about conditional. Conditional statement. What does a conditional statement look like? Symbolic-wise, the symbolic form of a conditional statement look like this: P, arrowhead, Q. So a conditional statement also has 2 pieces. Between the 2 pieces, we have this symbol for conditional statement. It's an arrowhead. It starts from P and point toward a Q. And the 2 pieces in a conditional statement play different roles. They have different names as well. P here, the piece to the left of the conditional statement symbol is called antecedent. This name, we should try to remember the names. Q here, the piece to the right of the arrowhead, is the consequent. Antecedent, you can understand antecedent as condition or premise. The thing, the condition that has to be met in order to lead to the occurrence of Q. Q is the result when P happens, right? When P happens, that directly causes Q happen. So Q is the result, is the conclusion. So we call Q the consequent. This point is different from conjunction and disjunction. Disjunction P or Q, the 2 pieces play the same role. The order of PQ doesn't matter. In fact, P or Q, Q or P, they are the same thing. They represent the same disjunction, the same compound statement. Conjunction, same, are also, it doesn't matter. In a conjunction, it also doesn't matter to switch the order of two pieces. P and Q, Q and P, it means the same conjunction. However, in a conditional, the two pieces play a different role. The order of the two pieces in a conditional cannot be randomly just switch. All right, we have to be very careful. The piece to the left of the arrowhead is called antecedent. The piece to the right of the arrowhead is called consequent. So that two pieces with the arrowhead in the middle gives a conditional statement. That's the symbolic form for a conditional statement. And then we also need to know how do we express a conditional statement in words, in English sentences, right? I'm going to give you 4. We actually have more than 4 ways to describe a conditional statement in words, but we only need to, I think it's enough just to know those 4. The first one, we express this conditional statement as if P, comma, then Q. Okay, if P, comma, then Q. We can also express this common statement, the conditional common statement P implies P arrowhead Q as P implies Q. In fact, that's how do I refer to this notation? P implies Q. If P, the condition is true, it should directly cause Q as true as a result. So I call this P implies. P implies Q. And the third way to express a conditional statement is P is sufficient for Q. The last way to express a conditional statement in words is Q is necessary for P. I'm going to give you examples to help you to understand those 4 types of ways to express a conditional in words. Number 1, number 2, number 3, number 4. Let me give you examples to help you to understand. Okay, so the first one, let's say P is working hard. Work hard. Q says success or succeed. Okay, and then P implies Q. So P, then we're gonna use different ways to express this conditional statement. P is the statement says work hard. A person work hard. Q is the statement says a person is successful, right? Succeed or achieve a success. Then P arrowhead Q, this notation represents a conditional statement says if a person works hard, then the person can achieve success, right? If P, then Q. So we can translate that way. That's the first way. We can also translate this as, if you work hard, then you can be successful as hard work implies success, right? If you work hard, then success will be a result. So P implies Q. Hard work implies success. So far so good. And give you another example. Let's say P P represents. Go ahead. Let's say P is a statement. It says, I take good care of the plant. Q is a statement, says the plant can survive. All right, then we consider P implies Q. We consider this conditional statement. We can express this conditional statement as, if I take a good care of the plant, then the plant can survive, right? We can also say, I take a good care of the plant implies the plant can survive. It also it's okay. Yeah, that way is okay. Well, we can say what? We can say, I take a good care of the plant is sufficient for the plant to survive. Do you agree? In this case, taking good care of the plant is the antecedent. The plant survives is the consequent. If I take good care of the plant, if that condition is met, and that condition is sufficient, is enough for the plant to survive, for the consequent to occur. So that's why the third way, we have a third way to express a conditional as P is sufficient for Q. The antecedent is sufficient for the consequent. Does that make sense? Okay, very good. Perfect. And if we say the consequent is necessary for the antecedent, if we say the plant can survive is necessary for I take a good care of the plant, maybe that doesn't make too much sense, right? Maybe it sounds weird. So some cases we use this is better, number 1 is better, some cases maybe 2 is better, some cases 3 is better, some cases 4 is better. Now I'm going to give you an example and use number 4 to express the conditional just to make a very good sense. So in this case, next example, I'm going to give you P here now represents Mike. Mike, we don't have a person, not Mike, right? Just randomly pick a name. Mike is a father. Q here is statement says Mike is a man. Let's consider the conditional statement. P implies Q. All right. Mike is a father is the antecedent. And Mike is a man is the consequent. So if I say Mike is a father implies or indicates Mike is a man, you will not disagree, right? Well, let's follow a traditional way. If someone is a father, you probably right away realize he's a man, he's a male, right? And we can also express that as Mike is a man is necessary for Mike to be a father. We do not consider other, high technology, AI, whatever. We only consider the biological part. If a person is a man, isn't being a man necessary for that person to be a father? If it's a woman, it's going to be a mother, right? So do you see what I'm trying to say here? We introduced 4 different ways to express a conditional statement in words. Those are 4 ways. Sometimes, use the first one, it just to make a better sense. Sometimes use the number 2, number 4, make a better sense. Sometimes use number 3, make a better sense, right? Depends on the situation. But we need to know all the 4 ways to express the conditional statement in words. The first 2 very basic. And the last 2, you will see them in MyLab Math. Just remember, antecedent is sufficient for the consequent. Consequent is necessary for the antecedent. Yeah, do not mess up the order. So far so good. So far so good. When you see if something something comma then something something, you're gonna know, okay, that is a conditional, right? If you see the words imply, sufficient, necessary, and you need to know, okay, that is a conditional statement. So far so good. By the way, if we have Q implies R, tell me which one is antecedent, which one is consequent. If you are looking at a conditional, let's say Q implies R, which is antecedent, which is the consequent? Q implies R. What's the antecedent? What's the consequent? Is R the consequent or antecedent? You can type. I can also type here. Please tell me in the conditional Q implies. Oh, I don't know where to find the arrowhead. Okay, I can just write implies R. Which one is antecedent and which one is the consequent, right? Can you answer me that question? P, I don't even have P here. No, so the conditional, yeah, thank you, Jack. The conditional I'm talking about is this one in the circle. Q implies R. I give you a conditional, which is symbolized as Q implies R. Yeah, I'm referring to this one. In Q implies R, which one is the antecedent, which one is the consequent? I don't even have P. I don't have P here. Yes, thank you, Jack. Q is the antecedent, R is the consequent. Right? Okay, perfect. Very good. And next up, we're going to talk about inverse, converse, and a counterpositive for a conditional. A conditional is pretty complicated. We're gonna give some definitions that pretty important regarding conditional statement. So we are going to call P implies Q the original. Let me rewrite this. We're going to call P implies Q the original conditional statement. Okay, and I'm going to show you what is the inverse of a conditional statement, what is the converse of a conditional statement, and what is the counterpositive of a conditional statement. Crystals, I am being sent home. We'll get back on when I get home. Oh, okay. All right. Drive safe. So let's say P implies Q is the original condition, is the original conditional statement. I'm going to give you three new definitions. So obviously in this conditional, P is the antecedent, Q is the consequent, right? If I negate both antecedent and consequent, if I negate both pieces, I will have a different conditional for sure, right? And this conditional definitely is different from the original conditional statement, but it is closely related to the original conditional statement. And we call this conditional statement, the inverse of the original conditional statement, right? If we negate both antecedent and consequent of a conditional, we get the inverse of the original conditional. It's just a definition. It's just that someone tell you my name is Jerry, right? So now I'm telling you this guy is called the inverse of the original given conditional statement. And both pieces, both antecedent and consequent, are negated. All right. So now look at the original. If I switch the order of the two pieces in the original statement, I will have a different statement, and that is Q implies P. Yeah. So if I switch the order of the two pieces in the original conditional statement, I would have what? The converse of the original conditional statement. All right, that's the second definition, converse. What is the converse of a conditional? You just need to switch the antecedent and consequent, and you will have the converse of the original conditional statement. And next, this time, for the two pieces in the original conditional statement, I'm going to do both things, negate both pieces and also switch the order. So I'm going to have not Q implies not P, and this is the contrapositive of the original conditional statement. All right? For conditional statement, we need to know the definition of its inverse, the definition of its converse, and the definition of its contrapositive. So it's pretty important. Inverse, what is inverse? What is converse? What is contrapositive? Okay, as an exercise, I'm going to give you an example. Let's do it together. In the example, P is going to be a statement says it is raining. Q is a statement says the grass is wet. By the way, the grass is outdoor and no cover. Okay, the grass outside your house is wet. So in this case, we are going to find the inverse for P implies Q, find the converse for P implies Q, and find the contrapositive for those. Okay, we are going to write the four statements, conditional statements, as words and look at their relationship. Okay, I assume you remember the definition of inverse and the converse and the contrapositive. Right, the first one, I'm going to write it as A. P implies Q. P implies Q. If it is raining, then the grass is wet. I think logically this conditional statement is true, is a fact, right? Of course, if it's raining, the grass will get wet. So that's the original statement. That's the original statement. Part B, I want you to help me to use the words to describe the inverse of the original statement. So I labeled this as A, okay? If it is raining, then the grass is wet. Can you give me the inverse of A, of part A? Can you give me the inverse of part A? If it is not raining, then the grass is not wet. Awesome. Thank you, Jennifer. That's correct. Let me type. Let me write it down. If it is not raining, then the grass is not wet. This is the inverse of part A, right? Very good, very good. Can you help me to write a converse? Let's label it as C. Can you help me to write a converse for A? How do we describe the converse of statement A? If it is wet, then it is raining. Yes, Cindy, thank you. That's correct. Yeah, thank you, Ashley. Jennifer's answer is correct. So the converse interchange or swap the order of the antecedent and consequent, right? So the converse of A would be if the grass is wet, then it is raining. That's the converse. Part D, I want you to help me to find the contrapositive of part A. This is converse. B is the inverse of A, C is the converse of A. Now D, I want you to help me to write a contrapositive of A. Give it a try. Contrapositive do both. Not only switch the antecedent and the consequent, also negate both of them. If it is not wet, if the grass is not wet, then it is not raining. Exactly. Thank you, Ashley. That's correct. You're right. If the grass is not wet, then it is not raining. Awesome. Very good. Okay, now let's look at A, B, C, D. D is the contrapositive. Let me write it down. Contrapositive. Now we want to look at the four statements. We want to determine the truth value for them. We want to know logically, in logic, is the conditional statement true or false? Does the conditional statement tell a fact or a non-fact? Okay, part A. If it is raining, then the grass is wet. What do you think? Does this statement logically make perfect sense? What do you think? Yeah, it is true, right? Yeah, of course, if it's raining, the grass is gonna get wet. Otherwise, I don't know. Has to be get wet, right? Very good. And what about the truth value for B? Let's read it. If it is not raining, then the grass is not wet. Logically, does this make perfect sense? In order to be a true conditional statement, logically, that statement has to make perfect sense. What do you think about this one? If it's not raining, then the grass is not wet. The grass has to be dry. I think it's false, guys. Think about it. If it's not raining, the grass does not have to be dry, right? If it's not raining, then the grass is not wet. Not raining does not directly cause the grass wet. The grass dry, I'm sorry. maybe your family just water the grass, right? You know what I'm saying? Maybe you just pour your water in the grass. So logically not necessary. It can still be wet after it stops raining. Yeah, that could be one, exactly. So logically it's not perfect, right? So the truth value for the second one is supposed to be false. Because not raining not necessarily directly cause the grass dry. There's the other reason can make the grass wet, right? Okay, I hope you agree with me. Part C, let's read the sentence. If the grass is wet, then it is raining. Sometimes maybe, you might have this happen in your life, right? And you sit in front of your by your window and you look out and you see the grass is wet. Would you right away draw a conclusion saying it is raining? What do you think? If the grass is wet, can you just draw the conclusion that it is raining? Yeah, you're right. Thank you, Cindy. It's false. Yeah, is C also false? Yes, actually, it is false. Yeah, you cannot draw that conclusion, right? It can be wet from temperature. Yes, the dew, right? Morning dew, or manually somebody just pour the water on the grass, right? We can't directly draw the conclusion it is raining. Of course not. So it's false. Okay, it is false. And what about the value of part D? If the grass is not wet, then it is not raining. Imagine you sit by your window and you look out, you see your grass is dry. In that case, can you draw the conclusion it's not raining? Logically, no problem, right? Yes, no problem. If it's dry, that means it's not raining. Because if it's raining, it's going to be wet, right? Okay, perfect. So the last one is true. Okay, and I want you to read part A and part D. I want you to read part A and part D and to feel the connection between the two statements. If it is raining, then the grass is wet. If the grass is not wet, then it's not raining. A and D are contrapositive of each other. A and D are contrapositive of each other. Yeah, we know D is contrapositive of A, but vice versa. The other way around is correct as well. A is also contrapositive of D. They are mutual. It's kind of like mutual. If two conditional statements are contrapositive of each other, they are equivalent. They are equivalent. They must have the same truth values. They either both true or both false, because they basically logically means the same thing. As you can see, A and D are both true in this case, right? Okay, let me say it again. A and D are contrapositive of each other. Logically, they are equivalent. If two conditional statements are equivalent, they must have the same truth values. Either they are both true or they are both false. So if you are a lawyer, you're going to deal with this a lot, If it is raining, the grass is wet. Another way to say that is if the grass is not wet, then it's not raining, right? Yeah, contrapositive is very important. Contrapositive is very important. And I also want you to look at B and C. In fact, B and C are contrapositive of each other as well, because we can probably look at these two pieces. This is B, this is C. This is B, this is C. As you can see, the order of the two pieces are swapped, right? P is here on to the left, but in C, P is on the right. Q is on the right in B, but is on the left in C, right? And also, B has both pieces negation. In C, they do not have the negation. So B and C are contrapositive. That's why B and C always have the same truth values. They mean the same thing logically. All right, I hope this explanation is clear. And a lot of things, when we make sense of stuff, sometimes we use contrapositive will help us, right? For example, yeah, a lot of things that we can use contrapositive to analyze the situation. For example, your husband came back home and smells like a alcoholic, you know, you would ask him, you must have drunk alcohol, right? Because what your statement, the statement you actually in your head is, if you smell like alcohol, you must have drunk alcohol. Otherwise, if you do not drink alcohol, you should not smell like alcohol. You see what I'm talking about? Sometimes contrapositive is really helpful, even in real world situation, could help us to make sense of things. Okay, so next we're going to, so we spend time to understand the definition of a conditional statement, right? Next, we're going to talk about the truth table of a conditional statement. Truth table. So far, we have learned 3 truth tables. We have learned negation, right? Yeah, let me quickly write them down. If P is true, negation is false. If P is false, its negation is true. Very simple. For disjunction, 1, 2, 3, 4. P or Q. The 4 cases for PQ, we follow the order TT, TF, FT, FF. Remember the sentence asks you to memorize. Disjunction is low maintenance, right? At least the one is true, then the disjunction is true. The only case a disjunction is false is when both pieces are false. That means all other cases true, true, true. Just like that. And we also earlier covered conjunction. 1, 2, 3, 4. The more times we write them, the more familiar we are with them. So PQ, this time is P and Q. Remember, conjunction means and. So it's high maintenance. And the only case for a conjunction to be true is when both pieces are true, right? The same with earlier TT, TF, FT, FF. The only case a conjunction is true is when both pieces are true. So the first case is true, all other FFF. Very simple. And now we're going to talk about conditional. 1, 2, 3, 4. P, Q, P implies Q, conditional. And the 4 cases are the same. TT, TF, FT, FF. All right? Okay, we have the 4 cases. We have 10 minutes. I'm gonna hurry a little bit. Alice, Bobby, Cindy, Danny. I'm going to use an example to help us to complete the truth table for a conditional statement P implies Q, or if P, then Q. And the example is me as a Professor Betty claims in the beginning of the semester, She claims if you here means a student. If a student study 3 hours per day, then you pass the class. This is my claim, the beginning of the semester. I say, if you study 3 hours every day, you'll pass the class by the end of the semester. Okay, so here, if we let the P be a student study hard, study 3 hours per day, Q is the statement, the student pass the class. Then my claim can be symbolically denoted as P implies Q, right? So that's my statement, P implies Q. I said, if you study 3 hours every day, then you will pass the class. My antecedent is a student study 3 hours every day. My consequent is a student pass the class. I claim if the antecedent is held, then the consequent will occur as a result. So that's my claim. Is that clear, everybody? Is that clear? So I'm going to give you an example. Now we are going to analyze the truth value for my claim in 4 different cases. The first case is Alice, second case is Bobby, third case is Cindy. I'm sorry, we happen to have a Cindy, but this has nothing to do with your name, okay? It's just A, B, C, D. And the last one is Danny, A, B, C, D. So the first case, Alice's case, T is true, Q is true. Sorry, P is true, Q is true. Alice studies 3 hours every day diligently. She passes the class. Think about, is Alice gonna be happy? Do you think Alice be happy? Of course, she passes, right? But also, in Alice's case, logically, my claim has no problem. My claim is true. I claim if the antecedent is met, if you study 3 hours every day, then you pass as a result. And that didn't happen to Alice. Of course, that makes my statement true statement, right? My conditional statement, my claim is true. So once again, Alice is happy. Yeah, no problem. Alice has no problem with my logic, the logic of my claim. Yeah, the problem is Bobby. In Bobby's case, P is T, Q is false. That means in Bobby's case, the antecedent is true. However, the consequence is false. Bobby studied 3 hours every day very diligently. However, by the end of the semester, he did not pass the class. What do you think Bobby will feel about Professor Betty's claim? He will be angry with me, right? He will not be happy. He will say, Professor Betty, you said if I study 3 hours every day, I pass. I did study 3 hours every day, but I did not pass. You know, in Bobby's case, logically, do you think my claim is false? Logically, do you think my claim is false? I claim if the antecedent is true, is met, the consequence will occur as a result. However, pitiful Bobby met the antecedent, but the consequence does not occur. So that does, yeah, it does make my claim logically false. Agree, guys? Yeah, Bobby is gonna be mad. You said if I study 3 hours every day, I pass. I studied 3 hours every day, did not pass. Okay, I logically false, right? In Bobby's case. And what about Cindy's case? In Cindy's case, P is F, Q is T. Antecedent is false. consequence is true. So Cindy's case, she did not study 3 hours a day. We don't know how many hours she studied, right? Maybe 4 hours a day, maybe 2 hours a day, maybe did not study at all, right? So, but she passed. Here, maybe it sounds a little weird. I need you to see in Cindy's case, my claim, not logically, my claim is not wrong. In Cindy's case, my claim is not wrong logically, because my claim gives an antecedent. I said if the antecedent is met, then the consequence will occur as a result. However, in Cindy's case, the antecedent does not met. Is not met, right? So really is actually pass or not pass will not make my claim wrong. Do you see what I'm talking about? Do you see what I'm trying to say here? Yes, exactly. In Cindy's case, you cannot say my claim logically wrong, because my logic is if you studied 3 hours every day, you pass as a result. But Cindy, basically, my claim does not apply to Cindy because the conditional, the condition, the antecedent is not met, right? Well, if the consequence occur or not occur is not what I claimed. I did not claim anything about what happened to Cindy. So that does not make my claim logically wrong. That is true. That is T. Same with Danny. Even Danny will be unhappy because he ended up with failing, but he does not study 3 hours a day either, right? He's not happy, but in Danny's case, you cannot say logically my claim is wrong either. Again, what I claimed is if the antecedent is met, if you studied 3 hours every day, then you pass as a result. When the condition, when the antecedent is not met, it really doesn't matter if the result occur, if you pass or not pass. That's not what I claimed, right? So logically will not make my claim false. So it's true. Okay, so that is the truth table for conditional. P implies Q. If P, then. And I want you to write down this sentence. The only case a conditional is false is when the antecedent is true, but the consequence is false, right? Because what I claimed is, logically, if my claim is true, when the antecedent is met, the consequence should occur as a result, right? So the only case that would make my conditional statement false is when the antecedent is true, but the consequence does not occur as a result. Like a pitiful Bobby, studied 3 hours a day but didn't pass, right? So I need you to remember this sentence. Whenever it comes to the truth value of a conditional, you need to right away remember that sentence. There's only one case. In the case a conditional statement is false, that is when the antecedent is true, but the consequence is false. To help you understand or help you to remember the only case a condition is false, I give you this trick. TFF, trusted friends forever. I wrote it very small. I wrote trusted friends forever. Okay, assume the first column is the antecedent, very important. P is antecedent. Q is a consequent. Okay, so normally we write antecedent follow with a consequent and then follow with the conditional, right? So if you have trusted friends, if you have antecedent true, consequent false, then you have false conditional. Trust friends forever. If you do not have trusted friends, those cases do not have trusted friends, those friends are temporary, TTT. Okay, just a trick to memorize, and you can come up with something else if you try, like three frogs fly, or you can just come up with your own trick. Here in the class, I'm gonna use trust friends forever. Okay, when you have trusted in antecedent, friends for consequent, and you have forever for the conditional. All right, we're gonna stop here and then continue on Monday. You should be able to work on the first two sections of chapter 3. Next Monday, we're going to mainly focus on construct truth table for complicated compound statements. All right, thank you guys for coming. Essential class, I'll see you in 10 minutes, and other students, I'll see you on Monday. You guys have a great weekend. You're welcome. Thank you guys. Yeah, see you in 10.